In lesson 8.2, we discussed matrices, kind of an introduction to matrices, some terms involving them, and some of the basic or elementary operations. So a matrix is a rectangular array of numbers designated with a number with an uppercase letter. So we're going to name matrices with capital letters. So let's say we might say matrix C is, and we want a rectangular array of numbers. So that means we should have some rows and columns. So this is maybe -3, -2, 1, and 5, 0, 16. And so it's rectangular. Each number in a matrix is called an entry or element. So we have 6 elements here in our matrix. A matrix with m rows. So rows are horizontal, and n columns is an m by n matrix. So we do rows by columns. So in this case, we have a 2 by 3 matrix, and we call those the dimensions. The dimensions of matrix C are 2 by 3. Each element in a matrix can be designated A sub ij, where I is the row that it is in, and j is the column that it is in. So if I come up here, this is matrix C, so I would use a C, lowercase c, and then maybe I could put a subscript of 1, 3. That means I want the element in the first row, third column. So first row, that's this row. Third column, that's this column, so that element is 1. All right, equal matrices. If A and B are both m by n matrices, then A equals B, where A sub ij equals B sub ij for all i's and j's. So you just want each corresponding element to be equal. And notice they do have to have the same dimensions. So in this example here, it says under what conditions are the matrices equal? We actually, just like before, we have a 2 by 3 and a 2 by 3. And we want them to be equal. Well, the corresponding elements need to be equal. So looking across here, well, A13 has to be equal to B13. So A13 has to equal 8. And A22 has to equal B22. So A22, second row, second column, has to equal -3. And coming over to matrix B, B11 has to be equal to A11, so it has to be equal to 2. And then finally, we have B23 has to be equal to A23. So corresponding elements have to be equal. Matrix addition. If A and B are both m by n matrices, so the dimensions must be the same, we cannot add a 2 by 2 to a 5 by 2. It has to have equal dimensions. Then A plus B equals C, where C, each element C in a certain position equals the corresponding positions added together. So in parentheses, it says just add corresponding entries, end parentheses. All right, here's another example. Let A equal 3, -8, 5, 7, -2, 0, and B equal -15, 4, 7, -7, -4, 5. Find A plus B, then B plus A. A plus B. Well, saying A plus B is going to equal, you're going to add all the corresponding elements. So I'll write this out for now. -3, -8, 5, 7, -2, 0. And we're going to add B to that. And we just add corresponding elements. So we will do 3, plus negative 15. That gives us a negative 12. And then we can do negative 8 and 4. That's negative 4. 5 and 7. Add those, that's 12. 7 and negative 7. That gives us 0. Negative 2 and negative 4 is negative 6. And 0 and 5 is 5. There you have it. There's a plus b. Also asked us to find b plus a. Well, it seems, so I'm going to do b plus a, so negative 15, 4, 7, negative 7, negative 4, 5, plus a. It seems like this should equal the same thing. And it does, because addition is commutative. Addition for matrices is commutative. So if we added these, we would still get negative 15 and 3 is negative 12. 4 and negative 8 is negative 4. 7 and 5 is 12. Negative 7 and 7 is 0. Negative 4 and negative 2 is negative 6. And 5 plus 0 is 5. So we see here that addition of matrices is commutative. Addition of matrices is commutative. All right. Let's keep working through here. A zero matrix, a matrix that has 0, has all of its elements denoted as O. This does not specify the dimensions, so O could come in different forms. O could be 0, 0. It's 2 rows by 1 column. O could equal, I don't know, let's say we have 2 rows and 1, 2, 3, 4, 5, 6 columns. Really, the form of O that we use depends on the question that we're doing. So in this next example, it says D equals that 3 by 2 matrix there. Find D plus O. Well, in this case, O, and if it's going to be added to D, needs to be the same dimensions. So it needs to be 3 rows by 2 columns. And if we add those, 0 plus anything is itself, so we get the exact same matrix. Nothing groundbreaking here. Scalar multiplication. There are going to be 2 types of multiplication. The first type is scalar, and it is pretty simple. It looks like the distributive property. It looks like, I'm not saying it is the distributive property, but it looks like the distributive property. If A is an m by n matrix, so a some matrix, and K is a real number, then K, the real number, times the matrix is the m by n matrix obtained by multiplying each entry of A by K. And so down in this example, this 2 is multiplied by our matrix. So each element, all 4 elements in this case, needs to be multiplied by 2. And that's why it kind of looks like the distributive property. This 2 goes to each element. And so we get negative 4, 8, 16, and negative 2. So that's scalar multiplication. Pretty straightforward. Next, we're going to get to matrix multiplication. Matrix multiplication is a little more complicated. You can see all this writing here. It says the product A and B of A and B is AB, where the number of columns of A, columns of the first one, must equal the number of rows of the second. So the columns of the first must equal the rows of the second. Before we can even think about multiplying, that has to be true. Where each entry, so each entry in the product is the sum, so we're going to add something together, add some things together, of the products of the entries from row I of A and the corresponding entries from column, this should not say row, column, no, actually, this one's wrong. Columns of A. This should say columns. This should say columns of J, or column, apologize for that, of B. The answer will have the same number of rows as A and the same number of columns as B. So let's just think about that for a second. When we multiply two matrices, if we have a 3 by 5, we can multiply it by a 5 by 2 because the columns of the first has to equal the rows of the second. And our answer is going to be a 3 by 2. So that's important to know. And it actually, if we can multiply them, it does work out, and you'll see that it will just end up being a 3 by 2. All right, so this says find A times B and B times A. All right, A times B. This is a 2 by 2. So first you have to see if they can be multiplied, and this is a 2 by 3. The number of columns from A equals the number of rows from B, and so our answer will be a 2 by 3. So now let's take a look at how to multiply them. So A times B will equal, and we're going to write them right next to each other, 2, negative 3, 0, 1, that's A, multiplied times B is 4, 6, 2, and 1, 4, negative 3. Now in all that writing, it says where each entry, let's highlight it here, is the sum of the products. So you're going to be adding products or adding things that are multiplied of the entries from row I of the first one multiplied by column J of the second one. So here's what that looks like. It's actually easier to see when you're just going through an example. So we will have first row, we'll go with our first column. So this ends up equaling, I'm going to erase that because you can't see it very well. Let's just do it this way. This is going to be 2 times 4, which is 8, plus negative 3 times 1, which is negative 3. So we are adding those products. Now we're going to move to first row with our second column. It's going to be kind of messy looking at the end. But first row with second column. So this is going to be 2 times 6. 2 times 6 is 12, plus negative 3 times 4, which is negative 12. All right, now we're going to go our first row with our third column. So this time we're going to do 2 times 2, which is 4, and negative 3 times negative 3, which is -9, and we add those together. So we did the first row with each column. Now we're going to work with the second row and each column. So let's circle our second row. We're going to be working with 0 and 1 now. So 0 is going to be multiplied by 4. 0 times 4 is 0. And we're going to add 1 times 1. And now we go to our second column. So we're going to do the circled black over there and the circled green. So 0 times 6 is 0 plus 1 times 4, which is 4. And we're on our last one now. We're still going to go with the 0 and 1, and we're going to go with the second column. So 0 times 2, 0 times 2 is 2, plus 1 times -3 is -3. And then we need to write our answer. So 8 plus -3 is 5. -12, or 12 plus -12 is 0. 4 plus -9 is -5. 0 plus 1 is 1. 0 plus 4 is 4. And I did this wrong. Hopefully you caught that. 0 times 2 is 0. And then 1 times -3. So we have 0 plus -3 is -3. And so that is A times B. All right. It also asks us to find B times A. So B times A, well, let's look at that. B times A, that is 2 by 3. That's B. It's a 2 by 3. And we're going to multiply that by a 2 by 2. And we find we can't multiply them because we know the number of columns of the first has to equal the number of rows of the second. And so we can't do that. So B times A is not defined. We can't multiply those, which just by this one simple example, we say that matrix multiplication is not commutative. All right. Let's move to our next example here. Here we want to find C times D, and then we want to find D times C. So this is a 2 by 3, and this is a 3 by 2. All right, so let's check out C times D. C times D, just as a reminder, we're doing a 2 by 3 times a 3 by 2. We will be able to multiply those because the rows of the first, or the columns of the first equal the rows of the second. And our answer will be a 2 by 2. So here we go. Let's actually multiply C times D. So C times D, we'll write them in here. 1, 6, -2, -1, -2, 4, multiplied by 5, -2, 1, 0, and -3, 3. I'm going to try something a little bit different here. So we're going to multiply these, and we're going to do the first row times the first column. All right, so let's check this out. We're just going to have an answer that's a 2 by 2, remember, 2 by 2. All right, so we do 1 times 5 is 5, plus 6 times 1 is 6, plus negative 2 times negative 3 is 6. All right, that was first row with first column. Now what I want to do is I want to just move this over. Sorry about that. Looks like I'm not going to be able to. Now yeah, there we go. Now I'm going to do first row with the second column. Well, this is going to be 1 times negative 2 is negative 2. 6 times 0 is 0. We're going to add negative 2 times 3 is negative 6. Okay. Now we're going to go down to our second row and go back to our first column. And we will do negative 1 times 5 is negative 5. Negative 2 times 1 is negative 2, so plus negative 2. And then 4 times negative 3, we're going to add negative 12. And then lastly, we are going to do the second row with the second column. So it will be negative 1 times negative 2 is 2, plus negative 2 times 0 is 0, and lastly, plus 4 times 3 is 12, and now we can find all these sums. Five, 6, and 6, that's 17. Negative 2, 0, and negative 6 is negative 8. Negative 5, negative 2, and negative 12 is negative 19. And 2, 0, and 12 add up to 14. And there is that product. So that was C times D. If we're figuring this out now, it also asks us to find D times C. D times C. Well, that is a 3 by 2 times a 2 by 3. We can do it, and our answer will be a 3 by 3. So let's try it. So we have D, which I have written here, is 5, negative 2, 1, 0, negative 3, 3, multiplied by C, which is this one, 1, 6, negative 2, negative 1, negative 2, 4. I'm going to go through this a little bit quicker. Our answer is going to be a 3 by 3, so I want to make a bigger bracket there. So we're going to go first row with first column. It's 5 times 1 is 5, plus negative 2 times negative 1 is 2. And now we're going to go first row with second column. 5 times 6 is 30, plus negative 2 times negative 2 is 4. Now we're going to go first row with third column. 5 times negative 2 is negative 10, plus negative 2 times 4 is negative 8. Now we go to the second row with the first column. 1 times 1 is 1, plus 0 times negative 1 is 0. Now second row with second column. 1 times 6 is 6, plus 0 times negative 2 is 0. And then second row with third column. 1 times negative 2 is negative 2, plus 0 times 4 is 0. Now we go to our last row with our first column. Negative 3 times 1 is negative 3, plus 3 times negative 1 is another negative 3. Last row with second column. Negative 3 times 6 is negative 18, and 3 times 2 is negative 6. And then we go our last row with our last column. -3 times -2 is 6, plus 3 times 4 is 12. And now we can put our answer. We have 7, 34, -18. In the second row, we end up with 1, 6, -2. And in our final row, we end up with -6, -24, and 18. So we got a little bit of practice multiplying matrices. All right, identity matrix. The identity matrix is a square matrix with 1 as every entry in the main diagonal. That means top left to bottom right, and 0 in all other entries. All right, so let's see what this has to do with anything. If A is this matrix here and I is that matrix that we have right there, that's the identity matrix. Just like the 0 matrix could have different dimensions, an identity matrix always has to be a square matrix, but it could be a 4 by 4, a 7 by 7, and you have 1s in the main diagonal and 0s kind of in those corners. So let's find I times A. I, which is a 3 by 3. A is a 3 by 2. So this is a 3 by 3 times a 3 by 2, so we can multiply those. So there's I, here's A. We can multiply them, and our answer should be a 3 by 2. So here we go. First row times the first column. We'll get an answer here. 1 times 4 is 4. Well, we have 0, so 0 times 1 is 0, and 0 times -2 is 0. So we just have 4. All right, let's go first row with second column. Well, we have 1 times -12 is -12. 0 times -7 is 0, and 0 times 8 is 0. Now we can go to our second row. Hopefully we start to see a little bit of a pattern here. 0 times 4, so first column is 0. 1 times 1 is 1, and then 0 times -2 is 0. First row, or second row with second column, 0 times -12 is 0. 1 times -7 is -7. 0 times 8 is 0. And then last one, we have 0, 0, 1. Well, 0 times 4 is 0. 0 times 1 is 0. And 1 times -2 is -2. And the last multiplication, 0 times -12 is 0. 0 times -7 is 0. And 1 times 8 is 8. And you'll notice that when you multiply the identity times any matrix, you will just get that same matrix. So the exact same as our matrix A. So there are the operations with matrices.